somewhere in the quiet darkness of space. Just 35 light-years away, a planet circles its star in near silence. No dramatic explosions, no glowing nebula, no cosmic violence. And yet, this small, unseen world may be one of the most important planets ever discovered. Because according to everything we thought we knew about planetary systems, this planet should not exist. Its name is L98-59F, a super-Earth, larger than our planet, more massive, and possibly shaped by forces we are only beginning to understand. It doesn't orbit a sun like ours. It orbits a red dwarf, a star smaller, cooler, and far more common than the sun. And yet, against expectations, this system produced a planet that challenges the line between rocky worlds and mini-Neptunes. Today, we are not traveling through space with rockets. We are traveling through evidence, through light curves, through gravity, through the quiet fingerprints planets leave behind. This is the story of super-Earths, and the strange, unsettling world known as L98-59F. For most of human history, planets beyond our solar system were invisible. We believed they existed. We suspected them, but we had no proof. Stars were points of light. Planets were ideas. That changed in the early 1990s, when astronomers detected the first confirmed exoplanets. Suddenly, the universe wasn't empty anymore. It was crowded. Hot Jupiters hugging their stars. Mini-Neptunes drifting in tight orbits. Worlds larger than Earth, but smaller than Uranus. And then, a new category emerged. Not gas giants. Not Earth-like planets. Something in between. We called them super-Earths. A super-Earth is not super because it has life. It's super because of mass. Typically, 1.5 to 10 times the mass of Earth. Larger radius, stronger gravity, thicker atmospheres. But here's the twist. There is no super-Earth in our solar system. Not one, which means every super-Earth we study forces us to imagine geology, weather, and physics we've never experienced. On a super-Earth, mountains may collapse under their own weight. Atmospheres cling tightly to the surf. ACE. Volcanism may last billions of years. Ours. Oceans may exist under crushing press. Your super-Earths are not bigger Earths. They're different worlds. And L98-59F might be one of the most extreme examples yet. L98-59 is a red dwarf star. Small, dim, cool. But red dwarfs are everywhere. They make up nearly 75% of all stars in the Milky Way. That alone makes them important. L98-59 is smaller than the Sun, cooler than the Sun, less luminous, which means its habitable zone is very close to the star. Planets here orbit in days, not years. And this star hosts not one planet, not two, but at least 5. Including one that surprised astronomers. L98-59F. L98-59F was not found by accident. It was revealed through a combination of transit data, radial velocity measurements, subtle gravitational effects. Unlike its inner siblings, L98-59F does not transit its star, which makes it harder to study. But gravity never lies. Its mass suggests something unusual. Too heavy to be Earth-like. Too dense to be gas-dominated. This places L98-59F in a rare category. A high-density super-Earth, possibly rich in rock and metal. And its orbit places it near, or within, the habitable zone. If L98-59F is rocky, its surface would be unlike anything on Earth. Gravity could be 2 to 3 times stronger. Walking would feel heavy. Falling would be dangerous. Mountains would be short and wide. Its atmosphere, if it exists, could be thick and dense, possibly trapping heat efficiently. Oceans, if present, would behave differently. Pressure would be immense, waves slower, currents deeper. This is not a friendly world, but it is a stable one, and stability is the quiet requirement for life. Life does not need comfort. It needs energy, chemistry, time. L98 to 59F may have had billions of years. If life formed there, it would not resemble Earth life. Photosynthesis might use dim red light. Organisms might be squat, dense, pressure-adapted. And intelligence, if it emerged, would evolve under a heavy sky and a closer sun. But here's the truth. We don't know. And that uncertainty is the point. L98 to 59F matters because it breaks patterns. It tells us planet formation is more flexible than we thought. Super-Earths are common. Earth-like worlds may not be the default. The universe is not built for us, but it is capable of us. And worlds like L98 to 59F suggest that the galaxy may be filled with planets that are stable, old, and quietly complex. L98 to 59F will never appear in our night sky. It sends no signal. It broadcasts no message. But its existence whispers something profound. That planets do not need to resemble Earth to matter. That the universe experiments endlessly. And that somewhere nearby, a heavy world under a dim red sun may be waiting, not to be visited, but to be understood.